So the title of this video is at the top, Introduction to Data. I'm going to cover some vocabulary terms that are important to sort of summarizing characteristics of data. I'm going to begin with a pet peeve. Data is not is, data are. These are data. Data, that term is plural for the individual piece of information, say 992, which is a datum. I may slip and use the singular form because it's become so common in everyday discourse to speak of data is. It's inappropriate though, so we're going to try our best to do it correctly. Speaking of data and individual items, which are datum. So, this is a spreadsheet, in a sense, or think of it as a spreadsheet, and the arrangement of data in the spreadsheet, something that should be already very familiar to you. Certainly for me, being a teacher, I've seen hundreds of these things over the years. Data that we'll use and analyze in R often will be arranged in this exact format. I've got here not just concepts being sort of broad, general ideas about some characteristic. I've got here, and this is a definition, I have here operationalized concepts. I have variables. The variables, these are observations, 1 to 10. The names, all the J names I could think of. Rank in school, freshman, sophomore, junior. I've included a number beside those. You could represent it either way, as what's known as alphanumeric terms, or just numeric data. Since in the last 3 digits maybe of your Ole Miss ID number, unique. And final 2 terms over here, grade point average, this is all made up, grade point average, and scores by these J-named people on test 1, say, in this class. These are variables. Now let's talk about some notation before I start describing what kinds of variables and different names of types of variables and different data. I'm going to work right here for a moment and encourage you not to get uptight. The math anxiety is such for some people that they sort of see something like this and begin to react negatively. It makes it difficult to learn. You all know this shorthand notation. I could do something more provocative, WTF. Shaking my head. Shorthand notation is ubiquitous in communication these days, especially. Always has been. You saw this for the first time and had no clue what it meant, and then either you Googled it or someone told you, and then afterwards you never had any problem again understanding exactly what this meant. So it can be, if you're willing, so it can be as well for notation that we use in describing data. First thing I want to talk about is the subscript, lowercase, squiggly letter I. This simply, I refers to an observation. I refers to a specific datum. I equals 1 is John. I equals 2 is Jane. I equals 3 is Joe, and so forth. So use that term, the subscript I, in a lot of statistics that we'll see going forward. And every time it's simply referencing the individual entries. An I represents a datum. Across I's represents data, the data set, and references individuals. I have here the small letter N and the capital letter N. We're going to use the small letter N to reference a sample of data typically that we have on hand, a subset of a larger set of data, often a larger set of data about which we want to make some inference using a smaller one. In many stat books, this division, small n versus large n, is described here as the sample size, and this then is the population size. You'll see down here, as you move across I equal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is n. That's the size of the sample we have on hand here. Say, you notice all of these are j's. With capital N here could be the entire class. All of the people with names starting with whatever letter. I have a systematic sample. The people whose names begin with the letter J, and n equals, small n equals 10. This is the uppercase Greek letter sigma, and very simply, this is important, it means add up whatever appears on the other side. So sigma, that often it's sort of added notation here, small letter n, small letter I equals 1. The added notation here is saying simply this. We're going to add up everything over here, beginning with I equals 1, and ending where I equals n, the total. We're going to add up everything. So we can choose one of these. We're going to say we're going to do GPA. We're going to add up, shaking my head there. This means in English to add up GPA, beginning with the first one and ending with the last one. I equals 1, summing across all the way to n. I can instantly make this a statistic that we'll see very shortly, simply by dividing through by n. This statistic, don't be scared, this statistic is the arithmetic average. This says add them all up, add GPAs up, and divide by the total. That would give me the class average. Likewise, if I replaced GPA with test 1, that would give me the class average on my first test. Again, an emphasis here on no panic, deep breaths, recognize that this is nothing different than learning shorthand notation associated with texting or shorthand notation that you might use in some other social media. Let's go back here now to variables. I'm going to finish this short section with unit of analysis. Go back up to variables. We get sort of in social science with concepts that we hope to relate to one another in some way. And a more sort of concrete definition of a concept is the finished product. A fully operationalized, write that down, fully operationalized concept is known as a variable. Pet peeve, just as data are plural, the word data. Variables vary. This is important. Variables vary. When you have an entry over here, if you had an entry over here that didn't vary, let's say every single person here was named Joe, that's not a variable, it's a constant. And we only have a variable when you have something that varies across the unit of analysis. Here, the unit of analysis is student. The unit of analysis is individual. These are individual data, gathering up information in a concrete way. These sort of describing names, rank, ID, GPA, and test 1. It is customary in referencing variables in the social sciences to make a division specifically between the first two terms here, dependent variable and independent variable. We'll get those defined and then probably back up a little bit and talk about relationships between them. This is y. I have y sub I and x sub I. A dependent variable, here's a definition, a dependent variable is the variable that you believe is caused by some other variable in the data set, and that particular variable that you believe is the cause, the independent variable. So this is the causal variable, and this is the effect variable. Might help, should help to give an example. I don't have a variable up here that I think is important, called attendance, or could be the number of minutes you spent watching the videos associated with the class, kind of participation. I do have scores on the first test, which would interest me, and I could very much interest me as in terms of what determines it, what influences it, what causes some students to score really high on my test, and so what causes some students to score really low. And so I sort of rename this one then Y. This is what I want to explain. Forgive me. This is what I want to explain, the Y variable, and I'm going to ponder what I have here maybe as an independent variable. Should write this down too. Sometimes people reference independent variables as explanatory variables. Some people even reference them as covariates. But in general in here we will use the term independent variable to define a variable that we believe explains another or is a potential cause. And here things get tricky, and a purist would interrupt me and say I'm going to do something tautological here. Tautology is where you have an explanation of an outcome and they're really the same thing. The weather causes the weather, whatever. I genuinely believe conceptually, though, and we're doing science, at least from the observational standpoint, I'm going to move from concept to variable, wondering about the relationship between GPA and Test 1. This class is populated by political scientists who have experience in the classroom where the GPA is earned across classes, have experiences that are quite unlike this one. This is a skills course, and it stands out in that respect relative to all of your other political science coursework, or it should. And so I have reason to believe that this is a measure of something different conceptually than this particular measure. This particular measure is gauging your achievement in this class, which is different than those from your past, consistent with the idea that we must establish that the cause came before the effect. Henceforth, we'll speak in those terms of X and Y, cause and effect. GPA, in this context, we'll assume, did in fact come before Test 1 in here. GPA references the students as they entered my classroom, hypothetically, and their achievement levels across all classes, but not classes that are really related to this skills course. And then I've got another indicator, a Y, a dependent variable, Test 1, that I wish to explain. This is the process, really, of thinking about relationships between variables. So I'm going to label this guy X1 and say this is an independent variable, a potential causal variable, and I'm going to say conceptually what it's gauging is general ability in the classroom, and conceptually what Y here scores on Test 1, conceptually what it's measuring is not general ability but specific ability in terms of mastering the course material here in the skills course, research methods. A third kind of variable that we'll see, and I'll give us several examples later, might even make one up right here on the spot, I'll label Z and call it an intervening variable. So I have this idea, a hypothesis that these two variables are related, that your general ability is going to affect in a positive way, really, your ability to score well on tests in this particular class. And we establish then what the X is and what the Y is. And now I'm thinking of something that might intervene in that relationship. An intervening variable is not one really that technically helps explain Y. It's one, I'm going to write this down, that explains the relationship between X and Y. So I started to, I ran out of room. I didn't include another variable, a measure of attendance, for example, or a measure of, again, the number of minutes you spent watching the videos for this class. It could be the number of times that you rewatch them or so forth. sort of an attention-oriented variable conceptually that measures the amount of effort, in a sense, that you put into preparation for test one. That will affect directly, you could call it an X, a causal variable. That will affect directly the scores on test one, but it might do something else. It might mediate the relationship between GPA and scores on test one. It might, in other words, mediate the relationship between general ability and specific ability as revealed by the test in the research methods course. It might. If it does mediate it, we would call it an intervening variable as well as an independent variable. Hypotheses are about variables and how they affect one another. Really good hypotheses are very, very, very definitive in what the expectation would be relative to a relationship. They would say which direction a relationship should move in. So we've got this measure of general ability and then a specific measure of ability. And you'd say, as you would expect here, the hypothesis would be that as one goes up across these observations, the other would go up as well, that higher GPAs would be associated with higher scores on test one, and likewise lower associated with lower. Going to finish up this short one with here with unit of analysis. These are individual data to your right, but in social science we use data and in different ways. This frequently will be the case. This should be an A. Frequently will be the case that we'll reference individual data, but recognize also often substantively we're interested in aggregated data. An example would be, in political terms, an example would be found readily in state politics or in international relations, where the actor is not an individual person, but instead a state that is an aggregation of individuals. Right now, for example, across the country, this is 2013, in prep for January 2014, when Obamacare kicks in, some states in the country are preparing to participate in the particulars of the ACA legislation that passed Congress in 2010. Some are preparing to participate, others are not. That's a variable across the unit of analysis that then would be state, and we can think of an explanation that would be an aggregation of individual characteristics or even opinions that might be something that would explain that variable. To participate or not at the state level in the Obamacare revolution, really, it's going to be, in the delivery and payment and insurance and healthcare and so forth. To participate or not could be our dependent variable, Y, and then we might be interested in an independent variable that characterizes the citizens of the state in ideological terms, maybe in partisan terms. What about this? What proportion of the people in each state, suppose we have not John, Jane, Joe, and Jill, but suppose we have Alabama, Alaska, and so forth, and then equals 50, and we've got this individual indicator of whether the state is intending to participate in 2014 or not. That could be our Y variable, and an X variable might be the proportion of people in the state that identify with the Republican Party. We know Republicans have been hostile to Obamacare, Democrats have embraced it, and the hypothesis might be that the more Republicans, the higher the proportion of Republicans in a state, the less likely a state is to participate. That X variable, the proportion of Republicans, is aggregated data, aggregated from the individual level. Many times in political science and economics and other social sciences, scholars are interested in studying variation over time. And so instead of an I, we might see this as T, then T minus 1, and T minus 2, and so forth. Then the T's could be weeks, or they could be months, or they could be quarters. And the variation could be strictly in a serial sense, that over time, as things change. These are called time series analyses, and we'll see some of them, at least in class. We'll work on some of this. And lastly, many things are a combination of all. Many data sets have combinations of all of these, individual, aggregated, across individuals, and time series. Write this down, pollster.com, and go to the URL. Just go and type it in, pollster.com. It's going to take you to a page now owned by the Huffington Post. This is a project started by an old friend of mine, purchased, and now sort of a journalistic site that's really heavily data oriented. If you go to that site, pollster.com, it'll send you to HuffPo, and on that front page, over to your right and down a little bit, you'll be able to click on Obama approval ratings. So click on the overall approval rating, and what will pop up is a set of curves over time, mapping approval and disapproval of the President of the United States, really probably back to the day that he was inaugurated first in 2009. So what those data are aggregations of individual surveys of individual people that are aggregated first, the people to a proportion of those that approved or disapproved, aggregated again across different polls, and illustrated over time. So those units of analysis there are all of these, and these are common. These are common now, increasingly, as data becomes more readily available from more different sources at more different points in time. It's increasingly common to not have one subscript, I, but to have many. You might have the I-th individual in the J-th survey at the T-th time. And that's common. We won't, in this class, we won't get to sophisticated analyses of combinations of different levels of analysis, but you should be aware that certainly they are. Okay, that's an introduction. More in a moment.